In this video, we're going to talk about how to calculate the rate of change of a linear function. So the rate of change of a linear function is the value of its slope. The rate of change of y with respect to x can be found by calculating the slope using this equation that you've seen before. The m equals y2 minus y1 divided by x2 minus x1. Remember that x1, y1, and x2, y2 represent points that are on the line. So let's look at an example. This table shows a linear relationship between x and y. What is the rate of change of y with respect to x? So this phrase right here, this rate of change, is the key phrase that tells you that you're going to be using the slope equation. So what we're going to do is we're going to identify 2 points and we're going to label them x1, y1, and x2, y2. Remember that your x and y values must stay together. So for example, if I label -3 as x1, that means that 13 has to be y1. If I label -2 as x2, that means that -9 must be y2. So make sure that you're keeping the x and y values together. So now let's plug into the formula. So we have m equals y2 minus y1 divided by x2 minus x1. So let's plug in the values that we have labeled. So we have y2 is -9 minus y1, which is 13, divided by x2, which is -2, minus x1, which is -3. So now let's simplify this. We have -9 minus 13, which is -22, and that's divided by -2 minus -3. Well, minus negative is going to turn into a plus, so we have -2 plus 3, which is 1, which gives me a rate of change of -22 divided by 1, which is -22. So let's look at another example. Let's calculate the rate of change of this linear function. So remember, I can pick any 2 points that I want as long as I label them correctly. So let's pick these 2 points. I'm going to label this -1 x1. That means 2 is going to be y1. If I label 0 x2, that means 4 will be y2. So now I'm going to plug into the formula m equals y2 minus y1 divided by x2 minus x1. So y2 is 4, so I'm going to plug that in. So 4 minus y1, which is 2, divided by x2, which is 0, minus x1, which is -1. So now let's simplify this. 4 minus 2 is 2, and that's divided by 0 minus -1. Minus negative will turn into a plus, so we have 2 over 0 plus 1, which is 1. 2 over 1 is 2, so my rate of change is 2. Remember, when you're picking points, you can actually pick any 2 points on the table. So I just want to show you that if I had picked a different set, that I would still get the same answer, because the rate of change is constant for a linear function. So for example, if I had picked this first point and this second point, and if I go and plug into my equation, I will get y2 is 0 minus y1, which is -2, divided by x2, which is -2, minus x1, which is -3. 0 minus -2 will turn into 0 plus 2, which is 2, and that's divided by -2 minus -3 will turn into -2 plus 3, which is 1. So 2 over 1 once again gives me a rate of change of 2. So you see, it doesn't matter which points you pick as long as you keep the x and y values together. So let's try another example. Let's calculate the rate of change of this linear function. So just to be a little different, I'm going to pick the last 2 points. So this is going to be x1, y1, and this will be x2, y2. So we can plug into the formula m equals y2 minus y1 divided by x2 minus x1. So I'm going to get this value of y2, which is -8, minus y1, which is -5, divided by x2, which is 3, minus x1, which is 2. So now let's simplify. We have -8 minus -5, which will turn into a plus. -8 plus 5 is -3. And that's divided by 3 minus 2, which is 1. So -3 divided by 1 is going to be a rate of change of -3. So remember that the rate of change of a linear function is the same as its slope. And we can calculate it using the formula m equals y2 minus y1 divided by x2 minus x1.